Hello, hello. Hopefully my audio is good and hopefully my video is good. I've tried to make VS Code a good size for it to be readable on stream, but also for there to be enough room for some code. hopefully this is good. Um, I should have pulled up GBJam. I should have here. So it's GBJam, and this year's theme is Unlucky. So for people who don't know, Game Jam is where people have a set time limit and a set of rules, and then they try to make a game in that time and within those rules. So the primary theme of this jam is that it's sort of Game Boy inspired games. There's a secondary theme every year. This year it's Unlucky, so make a game where some unlucky stuff is going on. The primary rules for GBJam are about the visuals. So you have to make art that is 4 colors or less on the screen at any given time. You are allowed to swap palettes, but you are not allowed to abuse this to get around the color limit. And your game can only have Game Boy controls, so 2 primary button inputs, 4 directional inputs, and then 2 additional buttons is all you get. Your game has to be 160 by 144 pixels or smaller. In terms of its internal resolution, obviously you're allowed to scale that up. And everything should be made within the jam, and you can't use AI tools. But beyond that, console accuracy does not matter, so you are allowed to use non-Game Boy audio, for example. You can use any technology you want to make the game. It does not have to be a valid Game Boy ROM. I keep seeing my mic clip and it's making me nervous. I'm going to move it away from my face a little bit more. Hopefully it's not horribly loud. Oh boy. But yeah, so GBJam is pretty cool. Our plan here is, so I'm a big C proponent. I do a lot of programming in C. After over a decade of experience of messing around with lots and lots of programming languages, I use C for basically everything now because C is one of the least bit rotting things that I've used. So I can write a program in C, come back to it years later, and it still builds easily. That's not true with basically anything else I touch. Except for arguably Vanilla.js for now. I have some friends who I'm trying to teach some programming stuff, and the easiest environment nowadays, like JavaScript, is the new basic, more or less. You can get some pixels on the screen with very little setup using JavaScript. So we're going to make our GBJam game in JavaScript, more specifically TypeScript. We're going to use Dino, because Dino 2 specifically, is a really great resource. It's designed for server code primarily, but we're going to use it as a compiler. So instead of using Node.js and Webpack and a bunch of stuff like that, we're just going to use Dino. So I'm going to go to my projects directory, and there's lots of stuff in here. So I'm going to make GBJam 13. There's GBJam 13, and then we'll open a folder here, and there's a file dialog GBJam 13. So here we've got our folder. Can you please? Sheesh. Okay. So now we've got an empty folder, empty directory, and now we're going to set up some stuff. I have such dry mouth, oh my goodness. Phew. I have a huge jug of water and a nice cup of Mountain Dew Baja Blast next to me, which will hopefully propel me through most of this stream. So, as you can see, we've got about 9 days here to make a fun little game. Most people will be working during that time, etc. I will probably also be working, although we'll see. I could have an unexpected amount of free time. Today, I don't know how much specifics of our game we'll get into. We might just be mostly focusing on setup because we are not using a game engine. We are not using Pixie.js. We're not using Phaser. We're not using anything. We're just going to use JavaScript Canvas, not even going to use WebGL if we can help it, and just kind of see what we can make. So in here I'm going to say Dino init, and it's going to say, I don't know what you're talking about. Okay, let's see. Dino, okay. So we have a Dino file, and this lets us configure tasks, and it lets us configure the linter and stuff, which is nice. So I'm actually going to change this from .json to .jsonc so that I can put comments in it. So I actually have, in a different window, I have some settings that I like to use. So first of all, we're going to be using the browser APIs. So we need to specify to Dino that we want to include the DOM definitions for APIs, and we're going to specify which standard of JavaScript we're actually using. We also we're going to configure the formatter for our files. So let's see, I'm going to change that. So there's our, well, I mean, single quotes are fine, but I don't really care. So there's our formatter options. And then we are also going to set up some linter rules. Set up the formatting options. And then we'll say set up the linter options. And then we're going to put some stuff in here to configure our linter. And we're going to use a source directory in this project. This doesn't really matter for this project at all. Let's see. So we have to put this here because Window is a deprecated API, and Dino because Dino is primarily used for like server side code, and we're going to be using it for client side code. So we need to turn off this deprecation warning about the Window API because we're going to use the Window API. And then we're just turning on all of their recommended linter rules. And I thought I had a link to the documentation about that that I could paste in here, but oh well. So that's going to set up our programming environment, basically. And then we don't care about this test file. That's going to go away. And then we have a goofy little main function here that we're going to change a little bit. So I'm actually going to set this up with, I'm going to set up VS Code tasks for a lot of things. We're not going to actually use Dino's task system probably for hardly anything, just because I'm used to VS Code tasks. But first, let's get something on the screen, why don't we? So let's go and we're going to make a new file called index.html, and whoops. If I could type, that would be so helpful. So we're going to have a head section. We're going to set the character set to UTF-8. All of these obligatory things. I haven't programmed on stream in such a long time. It's such a weird feeling. It's been maybe a year or something since I've done this. Let's see. Then we're going to link a style sheet that we don't have yet. We don't have any CSS, but we will have CSS soon. Not line. Link. Yes, silly baloney. Actually, I don't think we even need that. There's an error in my test stuff. So I've been setting up a little JavaScript environment lately for some educational stuff I want to do with a couple people. And so this is going to be based somewhat on that setup. So we're going to have a styles folder, and we're going to have a CSS in there, although we could just put it in the root directory. We're not going to have multiple pages here after all. And then we'll have a title, and we'll call this Game Boy Jam. Is it the 12th one? No, it's the 13th one. So we'll call it Game Boy Jam 13. Then we'll have a body tag down here. And actually, we'll just have it in the root. We'll be a little bit naughty, although we could put it in a thing. Make it source directory. We'll put our main.ts in there. And then we'll also have a, for now, we'll just put it out here. We'll have a main.css. And in our main.css, we'll leave it blank for now, but we'll style it in a minute. Okay. Sorry for being disorganized. It has been so long since I've done anything like this. So inside our body tag, we're just going to do some divs. Actually, we'll wait. Let's see, we'll put a canvas in here. Actually, tell you what. This should be more live than it is. So we'll do that. We're going to click Go Live. So here's our page. And now we can go and put more things in here. So let's go over to our main.css. And we are going to let's change some colors. So we're going to give it a dark background because, oh my god, that hurts. There's dark blue, a nice dark blue. And then, actually, is there a default margin or padding? I don't know. Yes, there is. There is a default padding. Okay, that's kind of interesting to know. We're going to change our text color, or which is just color, derp, to be white, and we'll change our, let's see, what else should we do? Actually, instead of white, let's do light gray. That's a little bit easier on the eyes. I'll do font size, it'll be like 24 pixels or something, a little bit larger. Actually, let's go even larger than that. That's too large. Okay. I promise we'll get to JavaScript soon. So there's that. And now we're going to go and we're going to go and we're going to put in a canvas. And we're going to set the ID to canvas because I'm lazy. Well, maybe we should call it something more descriptive like game canvas. This canvas doesn't have any properties, so it doesn't show up here. And then we need to set up our, if we want to do some JS, let's set up an include for it. There's not a file yet. I will say it's going to be a JS module, and the source will be build. Let's just call it index.js. That'll be fine. So now we need to actually set up our build. So we're going to make a new folder, call it .vscode. And then inside there, we're going to make a new tasks.json where we're going to set up our build tasks. Let's see, there needs to be a version string. I wish I could get all these freaking Copilot prompts to go away. Tasks, and then that'll be an array, and then we'll have tasks in here for our build and stuff. So let's see, label, yes, okay. So we'll call this bundle. This is going to build our TypeScript code into JavaScript that we can actually use in the browser. And it's going to be a shell command because we're just going to invoke Dino, and so there is a problem matcher for Dino, so we'll use that. So we'll have a command here. It's going to be dino bundle, and then we're going to tell it an output file that we want to use. So remember we said it was build index.js, and then we need to give it an input file, which is going to be source main.ts, and then we want to minify it, and we want to create a source map so that the debugger works. So there's that task, and then let's see, we also want to do, actually, can we go ahead and run that? So we say run task, dino bundle, no such file or directory. Is that because, hang on, maybe we need to make sure that there is a build first, or not. Okay, no such file or directory. Is that so? Wait a second. What did I do wrong here? Oh, that's a mistake. Okay, so now we've got this over here. I don't know if I actually needed that make dir. It should automatically make it, so let's just delete this build directory and we'll try that again. How did I, yeah. Module not found. Okay, yeah, so we do need to do that. So I'll have, oh, dir programming on stream is so distracting, and I hit the wrong keys. Okay, yeah, so it will make the directory. So this is our built deal, and this is the source map for it. There's nothing in there because we haven't done anything yet. So if I come in here, I could do, let's see, document query selector. Actually, we don't need to do that. We can use get element by ID, and we can say game canvas, remember? So we can get the canvas, and then we'll say if canvas exists, then we'll say canvas client width equals, I don't know, not client width, is it inner width? No, how does this work again? Is it just a width? I don't recall. Let's go look. Width? You lied to me. I see. HTML canvas element. There we go. Height. It's gonna be 144. Oh, wrong button. Okay, and so what we would like to have happen is to have this automatically run, right? And what the heck is it? Get context, right? And then you want a 2D context. We're going to use this to draw something, so we're going to say fill rect 0, 0, 160 by 144. We also need to set, is it called the style? Is that right? Context fill style equals sure. You can just specify a named color that way. Okay, that appeared not to work. Right, I forgot we haven't actually set up the full, there you go. So there's a pink square. So we've got some JavaScript running. So to go over this, we've got this main.ts file that we're in, right? And it's just got some code at file scope. And then Dino is taking that and building it into this minified JavaScript, and then there's a source map for it. So if I were to come over here and say inspect element or something, I could go to sources, and I could go and, well, it's not what I wanted. If I were to come in here, and I were to come right here and say debugger, then we would pause in the debugger, and we could come over here, and here it is. And so even though the actual compiled JavaScript looks like this, the source map lets us view the original TypeScript code and step through it in the debugger as if the browser was actually running that. So it's really, really helpful to have around. Anyway, ignore that for now. So here we've got our pink square. So let's go do some more stuff. Let's go set up another task. So this task is going to be Dino bundle watch, we'll call it. This is going to be, oh, go away you. So this one is going to be different. This one is going to be what we set our default build task to be. And actually, we should set this one to be in the build group as well. It just won't be our default. So this will be our default build, and then what this will do is it will set up a file watcher so that every time we save one of our TypeScript files, Dino will rebuild the JavaScript output file. So we want the same problem matcher here. And we probably want the same command, really. Dino bundle, I believe it's just watch, isn't it? Actually, we'll put that on the end with the other things. Watch. Okay, so now if I hit, I'm on a Mac, so Command-Shift-B, you will see that we have this task just running now. So if I go to main and I change this to be green and I save, as soon as I save, it'll rebuild and the changes will show up. Now keep in mind, I'm using the live server extension to do this, so this is not really live coding per se, because we're not keeping the state of anything when it rebuilds. We're actually refreshing the page. So each time that we do this, it's like the page is starting over from scratch. So like if there was a running game here, we wouldn't be able to preserve any state in that running game without doing some more work. But I think for the jam, this should be enough. Because in an environment like this, we'll set it up so that we'll have something where it's like, stop auto-completing. So you'll be able to say something like, oh my god, never mind. I need to change my settings. So you could have like a debug menu that you could just go and poke a value into easily, or you could even come here and you could press F12 and open this, and you could go to the console, and then in the console you could type in commands, and you'll get autocomplete when there's stuff in here to autocomplete. So I could have something like game.debug.do thingy and just do that in the web console if we set it up to let us do that. So it's pretty cool stuff. Phew. I'm so dehydrated, you have no idea. So what else do we have? I think that's pretty much all we need for tasks, really, and our JSON, our Dino.jsonc is pretty much done. So we can close some of these things. So now we more or less have what we need here. I mean, we could add some extra text around. So we could have like we'll say Game Boy Jam 13, and then we could have another div that's like a caption where we're like, I don't know, there's the theme of the jam, and then later we might put something else here on the page, like we could put like a loading screen or something built into the page. That's an easy, convenient thing to have. So let's see, we're gonna style the game canvas real quick. So we're gonna say that it's absolutely positioned, and we're gonna put it, can we do this? Can we just do like, hold on. what happens if we do, okay, so that puts it right there in the corner. And then if we say, now it's centered on the page. And then we're just gonna style it visually a little bit for funsies. So let's put a border on it. A black 4-pixel border. That's kind of cute, but I think that's a little bit much. That's kind of nice. So then we'll have a border radius. We'll put some corners on it. Try 8 pixels. Not bad. What about a little bit more? Okay. Which, I don't know, maybe that's not really in the spirit of Game Boy. Maybe we should keep it more angular. I don't know. We'll see. We'll think about it. And I'm going to put a box shadow on there just for... So there's black, and then no offset, and then we're going to blur it just to put like a little bit. So this is offset X, offset Y, and then how much blur around it. Black is a little bit harsh on there, I think. Let's bring it up a little bit brighter. That's nice. Okay. Moving swiftly along. So then we have the we have these top text and bottom text IDs, which we could make these classes, but meh. So let's also put this at a fixed position, and we'll just put it at like a fixed. We'll put it at like a fixed border from the side of the thing. So we're going to try to center this. Font size, we'll set manually. What was it before? I don't even remember. I think it's already 32. And then we'll do text align will be centered. So now it's in the center. And then we'll go ahead and set the color. Well, we've already set the color back there. So we'll leave it at light gray. We don't need to set the font size really because we set it here. Although I guess we could leave it for now. We might want to do some other default text size. Do the same number with the bottom text, but this one we will we'll make the font a little bit smaller so it's not okay. So now we've got kind of a crappy thing going on. And so this is the actual resolution that our game will be, 160 by 144 to match the Game Boy. But what we're going to do here in a minute is we're going to go right. Basically, we're going to scale it up. We could either scale it on integer scale based on the window size, or we could just scale it on subpixels. As long as we don't let things blur, it should be fine. So this for now, unless we add like a loading screen or something with some styling in it, this is more or less all our CSS is going to do, is pretty much this. So, and this is more or less all our index HTML is ever going to do. We might put a couple more things in here that we just want to have on the page, but by and large, everything is going to live in the TypeScript files. And then, of course, we'll have like an assets folder with sprites and sounds and stuff in it, and the music. We could, when it comes time to do sound, this is maybe off topic. When it comes time to do sound, we could use Web Audio API and make just like a normal bog standard game engine sound management situation. But honestly, for a game as simple as we're making, I'm thinking I might do something even simpler, which is just have audio, like generate audio tags and load our sounds into those audio tags. Because what we can actually do is we can add image and sound tags to the page, or well, we can not add them as children actually, but we can load those tags in JavaScript and then have like GET requests that pulls in our asset files, and we can write a loader that waits for those promises to resolve, and we can just let the browser do all of the lifting of loading all of our asset files for us, decoding our images and sounds, etc. And we can actually play the sounds from a tag, which is without having it like be visible on the page, which is kind of funny. So we might just do that. Some simple web games have done that forever, in lieu of having like a real audio node based system with web audio. So that is an option for us. I got off in the weeds. Sorry. I have a checklist. Where's my freaking checklist? Okay, I did that. Okay. So we did that, and we did that, and we did all of these things except make a game loop. So we need to set up a game loop. Make a game loop and then do some make a game loop and then do some basic rendering on this guy. But first we're gonna scale this canvas because I care about that immensely. So let's see if I can, how do we want to organize this? So let's, in our main, let's go just do this in main for now. So we're going to make a new function called fitCanvas to page. And what this is going to do is, we're going to go ahead and run it here. What this is going to do is it's going to fit the canvas to the page, whatever size the page is. It's going to scale it gracefully. So let's say we'll take some arguments here. So we'll take a canvas, which is an HTML canvas element, and we'll take a game width, which this is always going to be 160 in this case, but just for illustrative purposes. Game height, and then we'll also set a margin. Let's see. Well, I mean, we could keep it simple for now. We already know what these things are going to be, but let's say we take a canvas and so in here, and I'll do some logs for now. So we'll say fitting canvas, and we want to figure out the aspect ratio of the page, or of the canvas, right? So we'll have 160 over 144. So this is the game aspect ratio, right? We can have some more room here because these file names are all short. So we can have the game's aspect ratio, and then we'll have the window width is going to be, so remember in our deno.jsonc, we put the DOM here under this lib category, and we also turned off this deprecated window thing in the linter. That means that when I type window in here, I get autocomplete information. Now you notice there's a lot of classes on here, and that's because the window is kind of like the global context in JavaScript. So if we wanted to expose something, so like if I wanted to come in here and I wanted to, let me move this to the bottom actually. Can I do that? Yes. So if I wanted to come in here and like access something, so like if there was a debug thing or something, or if there was, you know, all of this stuff, you can also say, you can also access it from window. So window is kind of the global context. And so if we wanted to expose something, then we would say something like window fit canvas to page equals fit canvas to page. So TypeScript is complaining about this, right? Because that field is not specified, but whoopsie. But I can do this. Oh wait, sorry. I put that in the wrong place. I can do this. And that will silence the compiler. And then if I come here and I start typing, actually it didn't compile because we have an error right here. So let me just comment this out. Now our thingy is built. If I come over here, so fitting canvas, so our function got called by this line, right? But if I come here and I say window.fit, there's our function that we just added to the window here. So I can come in here and call it, right? And this will be called with null. But I could also just say fit canvas to page. and it also runs. So if we wanted to expose like debug stuff over here, we could do it this way. We would have like something like window as any, and then we would have like debug goodies, you know, equals, you know, something, our debug class, or whatever it is. So anyway, after that tangent, let's go set up this canvas. So we're going to say window inner width, and then we're going to subtract the margin, right? So we want to center the thing. We want to set the width such that we can have a margin of a certain size. Like if we don't have a margin, then we would cover up this text is the issue. So we don't want to do that. Window height. And so this one will be the Y margin. And we know what these are for this game, so I'm just going to go ahead and set default values. Let's try 32 for this. I think that should protect both of those. It might need to be more though. Now we're going to get rid of these unnecessary, well, we could leave them for now, who cares. So there's that. And so now we need to fit the canvas within these constraints, right? So we know how much space we have to work with on each axis, and we know the aspect ratio of our game. That is enough to scale it up. So if you were writing a native application and you were using OpenGL to draw, you'd clear your window to black, and then you would do this exact same calculation to scale. Like for example, if you were making a Game Boy style game natively, which I've done a bunch of times in C and other languages, then to scale my canvas up in that native window, I would use this exact same calculation. So we're going to start by setting the canvas width to the window width, and we're going to start by setting the canvas height to the there's a fly in here and it's driving me crazy. So we're going to use the aspect ratio to set this. Then if the canvas is too big on the other axis, we're going to then, oh my god, go away. We're going to limit it. Then basically, if we're too big on the other axis, then we're going to rescale based on that axis. So if the canvas is too tall now, we're going to change height to be the limiting factor, and then we're going to recalculate the width to be based on the height. So we're going to start out by trying to scale by the width. If that ends up being a problem, we'll scale instead by the height. And then we'll put a to-do integer scale option here. I'll show you guys how to do that. So then we're going to get our actual canvas, and we're going to set the dimensions based on what we calculated. And then, let's see. Then we're going to have turn off pixel smoothing. For some reason, this has to be done every time the canvas size is changed. That is something I recently learned. So if we have, so we need a context for this. So we need to say canvas get context 2D, and then we need to say context image smoothing enabled equals false. What did I do wrong? Silly. Okay. Well, okay, so we goofed that up a little bit. Let's change our margin to be larger. That's a little bit better. So I can't resize my window or it'll mess up my OBS setup here, but I can resize the console, and that is not working either. Is that because that doesn't count as resizing the window? Right, oh sorry, we don't have a game loop yet. I would have to refresh the page. And as you can see, it will resize the window to fit. Every time I refresh, it'll fit it within that spot, right? Which is more or less what we want. So we're going to take out this log now. And right, that should be game width. And this should be game height. Okay, so now we have a canvas that resizes. Once we have an actual game loop, we can, or well, actually what we can do, we don't need a game loop. What we can say is window on resize. We can pass in a function here. And so we'll say document. So in here we'll grab the canvas. Game canvas as HTML canvas element, and then we'll say fit canvas to page that canvas. And so now when the window resizes, we are resizing the canvas. It maintains its aspect ratio and it just works. So now that we have that, let's see. I'll show you, once we have actual images, I can show you what happens when this is not the case. So we'll say to do show what happens if we don't do this every time once there are actually images. Images. Okay? So we'll come back to that. So now, really quick, we could look at integer scaling. It's less illustrated without a picture here. We could maybe draw like a little something. We could wait until we have more set up. So we'll come back to this integer scaling thing. We could go ahead and show it. It just won't really matter much is the thing. So let's put this in its own little bubble here, and we'll say canvas width equals. Oh, right. Okay, we'll need to do some extra work here. So we'll come back to this. Mark my words. Also, we should probably set up a Git repository. Canvas first commit canvas scaling. Okay. And so then what? Let's see, we are about, oh my god, it's taken 54 minutes just to do this because I talk too much. Phew. Alright, well, I could take like a 15-minute break and get some water and then come back. So let's see, what's next? Next, we should do the game loop, I think. Why? Okay, for a second I thought my mic was messed up. So let's see. So we'll say, next up, game loop. And then, could I put a timer on screen or should I just go to a tab? So let's have 10-minute timer. And I should probably leave that muted actually. So I will return in back in 10 minutos. Alright, I might be back sooner than that, but I will be back momentarily and we'll do a game loop. Next thing. Game loop. Then basic input or something. All right, we'll be right back. All right, we're back. So, can I just like, nope. That's not what I wanted at all. I wanted to take this back to normal size. Okay. So, the next thing to do is we're going to set up the game loop. So, let's see. I'm going to put in some, well, okay. I like doing little markers like this to demarcate sections in my files. It's something I got from doing C programming, but I end up doing it in a lot of other languages just because I can do this and hop around on a big file. Anyway, let's see. So game loop time. How do we do the game loop? Which there's also other things we need to do. So a lot of stuff we're going to do in our game is going to be by doing we're either going to set an event callback on the window, so it'll be like on something, like on resize, like we did before. It'll be something like that, so we set that here, right? Or we'll do something on the document itself. That's another option. So on the document, we're going to add an event listener. Actually, is there one of these on the window? Is that true? Is there a context menu? No, there's not. Okay, so on the document, so you can set a function callback like this with certain names on certain things in the DOM, but for other things, you have to add an event listener to a list, and this is one of those. So when you right-click, that is called the context menu, if you didn't know. And so what you want to do is you want to disable that in your game so that if somebody clicks right-clicks, I should say, on the canvas, we don't want that to happen. So now we've turned it off. So what this is saying is, so this is a function that will take the event, which is E, it'll take that event and do something with it. Prevent default, calling prevent default on that event means stop the default behavior from happening, and in this case the default behavior is popping up the context menu, so we're turning that off. So I'll write that down. Do not summon the context menu on right click. So we're turning that off for our entire page. We've got our resize handler here. What else is there? There's technically an E here, but we're not actually using it. But just for completeness, I'll go ahead and put that. So we'll say handle the window resizing, resize our canvas. What else do we want to do? So we are going to set up the game loop. So, and we can also do things like, here on the page, I'm setting the page title to GBJam 13, but here in our code, we can just set it to whatever we want. So now you can see it's changed to baloney up here. We can just do that. So what might be easy, something that I typically will do, is I'll have like an index.html that just has things in here like to do or whatever, and then in the actual code I will set the title to something based on the current project. So in one of my games I have like export default project, and then I have things in there like title is whatever. And so then I can say things like document title equals project. Well, the autocomplete's not going to want to let me do that, but you know what I mean. So let's say document title equals unlucky day. I don't know. Whatever it is. So we can do that. We can also set the text, right? So we can do that. So I could say document get element by ID, and I could get that top text, right? And then I could say that the exclamation point means I'm asserting that it definitely exists. And then I could set the text to be like thingy mabob. And so there you can see the text has changed. So we could do this to set like a title and description on our game without even leaving our code and going back to the page itself. We could leave the page the same. That's just an example. But anyway, so I'm going to grab these and I'm going to move them up here. And then we'll keep adding event listeners that we need. So let's see. We do the fit canvas. We have a resize thing. What else should we do? Well, let's see. Set up our game loop. We're going to need to keep up with when the last frame was, and then we're going to want to have a function we're going to want to have a function that we can call every frame. So I think, so on this monitor, for example, our refresh rate is going to be 100 hertz a second, and this game will not do anything to ever go below that. But I should also say, normally I would do a frame rate independent fixed time step, but for this game I'm going to experiment with having a variable time step. But what we will do is, if the game is running particularly slowly, we will just lag the game. So we will not, if the game is running slower than 30 FPS, then we will just lag the game and it will run at a fixed 30 FPS time step, because if we get to super long time steps, it could make things behave weirdly, and we don't want that. But I'm fine trying to code a game that's stable between like 30 and 120 FPS, which should cover most monitors and most like hardware capabilities that the game will be running on. So let's get, we'll call this the raw delta, which is going to be the current time minus the last frame time. And we're going to divide that by 1,000 because these numbers are in milliseconds. They're going to be in milliseconds, and so then we'll have the delta time, which, so we'll check if the raw delta is greater than, well, is greater than 1 over 30, then we're going to use 1 over 30, otherwise we'll use the raw delta. So what this does, as we just said, so if we're running slower than 30 FPS, lag the game and run at a fixed 30 hertz interval. Well, not interval, frame time step. Note. Oog. I'm getting one-shotted by nitpicking the formatting of things. Not good on stream. Okay. And I hate this notation, real talk. Let me just be old school for a second. That's better. Okay. So, there's that, and then we'll set our store our timestamp for the next frame. So we're going to say that the last frame time now is going to be the current frame time. And then we will clear our canvas to a color. So we're going to get the drawing context for our canvas. And then we're going to assert that that exists. We're going to set the fill style to be, let's try black first. And then we'll fill a rect from 0, 0. And it'll be the full size of the canvas. And then to do, here is where the game updates and draws, and then continue the game loop. And we'll say request animation frame, and we'll pass our frame callback in there. So this is a weird thing that you do in the browser, which is each frame calls this, which will then call back the following frame. This is very weird to people who are not used to web development, but this is how you get this is how you get a good refresh rate for your web game or your web app or whatever it is. And we actually need to start this, which is why the canvas over here is still transparent. Actually, start the game loop. So we started off by calling this. Boom. Now we have a blank canvas. And our resize still happens and all that stuff, right? So if we come in here and we put something like, if we come and do that, then over here in the console you can see all of these frames are accumulating, and it's logging every frame, and you can see it's really schmoovin because this is a 100 Hertz monitor. So here soon what we'll do is we'll add an FPS display. But you can see it's really going there, so we're going to turn that off. So there is the basics of what a game loop looks like. Let's make this a little bit less dark. That's better. Okay. At the end, I don't know if GBJam frowns on this. We might have some optional filters. We aren't going to do like a proper CRT shader because we're not even using WebGL, but we might do something like some simple scan lines, maybe a little bit of blur or something. I don't know. We'll see. Really, you'd want to do like an LCD filter. That would make the most sense. So here is our basic game loop. So let's, which we're not doing anything with it yet, but go ahead and commit this stuff. Okay, there's a super basic game loop. And we're still all in this one file for now. So next, what do we do after the game loop? Well, after that we should let's make a little rectangle and have him move around. So basic input, we'll call it. So what we're going to do now is I'm going to make a new folder in here called game, and this is going to have all the specific stuff for this game in it. I'm going to make another folder called lib, and lib is going to have all of the sort of utility stuff in it. So if I have easing functions or animation stuff, things like that, that's where it will go. And as you can see, we're not currently using this delta time. That's because we're not actually doing anything in our game yet, but we will shortly. I'm running low on Baja Blast, but I have another one here, so fear not. Alright, so doop-a-doop-a-doop-a-doop-a-doop. So let's see. Do we want to use classes for this? We could. That would make some things a little bit easier. I debated the whole time whether or not to use any of my own existing libraries here. There's also other people's libraries, like Suchipi has a really good game controller wrapper that we could use, but typically I just write things myself. And I have an input wrapper that I could use, and it is but it's only like 200 lines of code, right? So I'm like, I mean, I could just do it myself and on stream. I could just rewrite it instead of using it. Depends on how Handmade Hero I want to be about this, I guess. And I don't know what anybody watching would think or prefer. So we could, I know that we're going to want to be relatively organized on this later. So we could go ahead and get a little bit organized now. So let's make a file called config.ts. And in config, we are going to put all of the high level like metadata and config about our project. This won't take long. So we'll call this config, and we'll throw some stuff in here. So we'll have title, which will be Game Boy Jam 13, name me, and then we'll have a version string, which is just going to be nothing important. Description, Game Jam game about unlucky something. And then we'll have authors. This stuff will maybe come up later in credits or something. I mean, we don't even need to go this far right now. So we'll have these things, let's say, and then we'll have game width, which is going to be 160. Game height, which is going to be 144, because it's Game Boy, and then we'll have page margin X is going to be like 32, and Y is going to be 64, because I think we're doing 64, right? Yes, we're doing 64 for both, but really for X, I think you could just do 32, because even if, because there's no text there to get in the way, it would maybe feel a little less crowded if it was 64, though. Yeah, that's kind of nice. Maybe we should just leave it at that. But then what if somebody has a really tiny device? Their problem. We can deal with it later. We'll see if it feels bad in practice. I feel like on a small phone that would feel bad. Anyway, so there's that. And so then, do we even need to nest this like that? Because then we have to do, don't we have to do this, I think, to make sure that it can't be changed. Whatever, it really doesn't matter. And then we'll have other high level settings go here. And so later, when we have stuff on screen and I'm going to do that integer scaling, we can make that integer scaling a, we can have something like this. We can have something like integer scale false, or integer scale true, etc. We'll be able to do stuff like that later, and our other files can refer to it. So if I come up here, I can say import config, and so then what we'll do here instead of this is we'll say config game width, config game height, config margin X, margin Y. And so now we have all those magic numbers removed and put somewhere we can just change them. So if we wanted to reuse this later and make like a normal sized thing, we can just go change it in our new project. Any hootie. Okay, so there we've got that, and then we might also want to do this to allow either side. I mean, I know some people just really don't like the import default because it, like, I don't know. I don't really know what the argument is there, actually. I'm not enough of a JS person, to be honest with you. Anyways, rendering input credits, maybe. I'm not sure if we might put the credits in here, or we might make a whole like scene for the credits. I don't know. Anyway, so there's that. We need to do some basic input. So first thing I'm going to do is let's do this. So we'll have tech.t. Well, we probably want to make. Do we want to make the game like a class? Because I feel like that will be the most familiar to the most people if we make it that way. Maybe a bit outside my wheelhouse, but we should maybe do that. For now, we'll do it that way. So we'll have game.ts, and we'll have export class game. All my C homies are cringing in the chat. And then we'll have a constructor, which will do whatever init stuff. And then we'll have an init function. Well, no. Why would, whatever, dude. So we'll have an init, we'll have an update, where we'll take a delta time, and then we'll have a draw. And that should be enough to make a game, frankly. And so then what we'll do in main.ts is we'll import a game, and we'll have a game. So here, prior to doing that, we'll say set up our game. So we'll say const, actually we'll put it down here. Const GGame, or we could even say like window.game or something. We'll say const game equals new game, and then we'll say window.game equals game, and then that will let us get it for debug stuff. Okay, and then okay. And then down here we'll do, let's see, game init, and then in here we will say game update delta time. So that will actually update all the state of the game, and then we will draw the game. And we could pass in the canvas, or we could pass in the context. None of this really matters. We might even, whenever we create the game, pass in the canvas. So we could say public canvas HTML canvas element. We could take a canvas there, and then here we'll give it the canvas, which we have from way up there. Alright, so there's that. So now we've added the canvas to the game. So in draw, what we'll do is we'll say this.canvas get context 2D, and then we'll say context. Oh, we're gonna need to scale this, I think, but we'll try that in a second. So we'll set the fill style to be green, and then we'll try filling a rectangle. 0, 0, 16, 16. Okay, yeah. So here's this tiny little green thing, which is actually 16 by 16, but we need it to be scaled based on the reset transform. Okay, and then context scale. Oh boy, what is our scale gonna be? Canvas dot inner, no, dot width divided by config width, game width, and then we'll have this canvas height divided by config game height, and then oh, that's not what I wanted, you silly. Okay, so then now it's the right size. So because our canvas scales, we can compute the scale, the relative scale, and then draw things at the correct size. Which we technically don't need to do this. We could just compute this once, but this will be fine. So we'll say scale to the proper resolution. Draw a test rectangle. All right. To do more drawing. To do the updating. To probably reset some data structures. Okay, so with this, we've now got a basic scaffold for some stuff. So we have this delta time here. We could do something like we could have game time, which is starting at 0, and then every update we could say game time plus equals dt, and then based on that we could say something like math sine this game time times pi, and then we could do this. Hold on. We could do something like that. Game width minus 16, that's what we want. So now it's gonna, when I save this, our little green box is gonna move. Well, I screwed it up. Where did I screw it up? Ah, yeah, that's where. Whoop. So now our green box is gonna move back and forth. And so the way this is working is every frame we are running this update. It's counting the time, it's getting the time that's passed since the last frame, and then in the draw we're getting this. And obviously I can come in here and change anything I want, and it will update same as before. And you'll also notice it's starting over from scratch each time. It's not like keeping our state. So we've got a little guy that moves back and forth. And the next thing to really... Why is my mouse frozen? That was strange. Anyway, so there's that. And the next thing we could do is do some actual input here. So let's see, how do I want to handle this? Where it is GBJam, there's a fly in my room. I really need to get a new screen for this window. Excuse me. Doop-a-doop-doop-doop-doop. So, we need an input library. Where it's GBJam, we're going to be limited to A, B, select, start, and directional buttons. I'm going to set that up on the keyboard first, and then we'll boot up ye old gamepad here. I said we'll boot up ye old gamepad here, and then we'll do some gamepad input too. So let's start on that, and we can use that to move around. We'll have a player, and the player will start at config game width divided by 2. So we'll have a player, and then we'll draw our player. Draw our test player. So we'll have a player, and our player will be at this.player.x -8, this.player.y -8. We're centering it basically. So there's our super cool player, and then our job is to move our little orange square around with the input library that we're going to write. So to do, move our player around the screen. So let's go and write an input system. Now this is going to be general purpose and not specific to this game, so I'm going to put it in the lib folder. We'll call this input.ts. And let's see. So we might want stuff like the mouse state for debug, but for GBJam we're only allowed those specific inputs, so we might just wait. So I'm going to make this a class just to keep everything, and we'll call this input manager. Or we could call it input system, but then people associate system with ECS architectures nowadays. I don't know, input managers may be fine. So then in here, we'll record some states for the different keys. So if you don't know TypeScript, this open close curly bracket in JavaScript is just creating an empty object, which acts like a dictionary, right? Same as in Lua. This record string boolean is just telling TypeScript how we're going to treat this object. We're going to treat it as if it's typed and if it has this type. So we're going to index it with strings to get values that are booleans. And so TypeScript will treat it as if we've created a class that has those properties. And then we'll also have a gamepad state and stuff in a minute. We'll also have some inputs which are going to be like named, I think. We'll wait on that. So for now, let's just do keys. So we'll have a constructor, and then inside the constructor, we'll have init the keyboard parts. So for this, we're going to add a window event listener. We're going to listen for key down events. And then we're going to take, actually, this doesn't need to be complicated at all. So keys, let's just call it keys. So each key event has a code, and so for that code, we're going to set it to be true. And then we'll also add an event listener. What is the complaint here? Compatibility. I've literally never seen. I thought I turned you off, didn't I? This one will be key up, and it will do the same deal. So we're not queuing up events here. We're just tracking the current state. Your game might not want to do that, but for our purposes, I think it'll be just fine. Why am I getting this warning? It doesn't actually matter, but why am I getting it? And here we want to import the input manager, which we're not currently using, but we'll go here and we'll have input equals new input manager. And so actually what we'll do, we'll say state. So here's all the state for our game, and here's all of our systems. And then here is our methods. All right. So there's that. So this will have us tracking input events from the keyboard. And then what we'll do is, let's see, we could have a method in here that's like is key down, and we'll take a key code, which is a string, and then we'll return key code. So we could, yeah, we'll leave that as a boolean for now. We'll do this. Whoop. So even if it's null, we'll get a boolean value back. And yeah, I think that's fine. We could detect things like key presses pretty easily. So we could have like keys previous frame. And then do something where we update we like need to do a deep copy every frame and do some other stuff. So for now we won't do that. We'll track it a different way. So let's see. So there's that. And then what else do we have? So we're going to go and use this for our little orange guy. So we'll have if input. Actually, here's what we're going to do. Well, so we'll have move x, and we're going to say if input is key down. Is it just called like left? I don't even remember. We're going to find out. Then move x minus equals 1. Right. Yes, this is very goofy and rudimentary. And so now these are going to be, whoopsie. We're going to have a move y as well. This will be up, and this will be down. And I really hate how much space this is taking up on screen. And so then what we'll do, for now, we'll just say player x plus equals move x, player y plus equals move y. So this is going to be tethered to the frame rate, but we'll see if it works. And it doesn't. It does not work. Why not? So let's go and check out the game. So now we can inspect all of our data, which is super cool. This is one thing I really like about Chrome DevTools and Firefox DevTools is I can just come in here and I can look at these, and they are not updating. They should be live updating, but they are not. Right? They should live update, I want to say. Okay, maybe not. That's interesting. Or is it that they resolve when you open them? I don't recall. But we could also open the watch window and put stuff in there. So those are happening. So what gives? Minus equals 1 plus equals 1. Da 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 da. So we did guess the names correctly of the keys. Are we not actually using it correctly? No, we are. We do appear to be using it correctly. So what is our mistake here? Well, what we can do is, well, we could call the debugger here and step through. Oh, that cup no longer has a straw in it. Man, I have not done a programming stream in such a long time. Feels very strange to be back. So we're gonna do some printf debugging here real quick. We're gonna print that out every frame. Right, we know that's not changing. So let's do this. Right. Am I crazy? So these are okay, so these are, duh, I did get the names wrong. I can't read. Sheesh. Yeah, okay. Yep, so there's our little critter moving around with the arrow keys, but it is frame rate dependent. So this is a 100 hertz monitor. This guy will move roughly 100 pixels in a second. We want to make it frame rate independent, so what we're going to do is we're going to have a speed here. Let's say, now if the speed is 100, it should be roughly the same. Times speed times delta time, dt for short, and it's about the same. It might be a little bit faster there. And now we've untethered the frame time from the speed. We can set it to whatever we want. So if we want to move 64 pixels or 2 of these in a second, now we're doing that. And let's say that we wanted to only render this guy where we're pretending to be 160 by 144. We want to show this guy at pixel coordinates within that resolution, right? So what we could do is we could come in here and we could do this, which will round his coordinates to an integer. And you can't really see that much of a difference because it's quite smooth actually. But if he was moving even slower, let's say we made him move quite slow. Now you can see that he's inching along in discrete steps. Each one of those is a pixel. So if I bring him over to the edge, there's 1 pixel, 2, 3, 4, 5, 6, 7, 8. There's 8 pixels from the edge. Isn't that nice? So this is one way to render things in a pixel perfect positioning scheme in a higher res like situation. And in this project, that's probably what we'll do for most stuff. Like anything that's not a debug display will probably be using a rounded position like this. And my monitor, my silly OLED monitor has dimmed itself because the screen isn't changing enough. Okay, whenever that happens, I have to go drag something around the screen. Okay, so now we've got an animation playing at a set rate, and we have a little guy moving at a set rate, and la-di-da, and we're having a grand old time. So this is going to be enough to do some basics. Now throughout the game, we're going to also want to do gamepad input, and we're also going to want to do, it would be nice if we could say, you know, is the player trying to move left, and have that be checking keys and gamepad inputs, right? So we'll make a little abstraction around input. So this is already enough to get keyboard input in the browser. you know, you don't even have to make this a class. We just did. This is like 3 lines of code that actually matter. Super trivial. The browser is very generous. But so let's make a little bit of an abstraction around this. So let's say that we have another class in here. It's like, let's say we have something that's like input wrapper, or input named input, or like tracked input. I don't know what we should call it. Input state. That's not very descriptive. So we'll call this like, I don't know, wrapped input. Let's do that. Or we could call it like input button, maybe. Input button. That's not terrible. In here we'll have down, which is a binary state, and we'll have was down, which refers to the previous frame. We'll have a value, which is a number for things like an axis. So we're going to support joysticks as well as the D-pad. And then we'll have a previous value, which is for storing. So this is the prior frame. So the state, the prior frame, the value, the prior frame. And then we'll have an update function where we'll take a value, which is either a number or a Boolean, and we'll check this. And some folks might say, well, that's going to be inefficient, isn't it? Not really, because the number of these things happening is incredibly small compared to things like collisions in your game or whatever. This stuff is not going to be a bottleneck for you. So if it's not a number, we'll do that. And then this was down. Is this down? So we're going to update each frame this. And then we'll set the previous value. It's going to be the current value. So this is storing the current frame for the next frame to use. Or rather, storing the previous frame for the current frame to use. And then setting the new value for this current frame. So basically, when we have one of these input buttons, we'll call this on it every frame. We're going to put these in a big array or table. So then we'll have is pressed. So if this input is down, and it wasn't down on the previous frame, or actually was, well, that there's vagaries here. Pressed, released, return this was down, and not this is down. Okay. And then we'll also just have, oh, we can't do that. We just have to read it. Okay, well, I'm writing this in a C way where it's like, I don't care about privacy because I'm not going to do anything stupid because this is not an enterprise software team. Let's see. Which I always thought code architecture as documentation for some rando was not a very good way to do that, like to store that information. Like storing that as part of your architecture always seemed weird to me. Anyway, moving swiftly along. So we have these guys now, and we're going to use this to kind of have abstracted inputs, so like left, right, up, down, that can refer to multiple different things. So it could be WASD or the arrow keys, for example. And we could make a thing where we could like register this and be all fancy. We should do that later, but for now we're just going to hard code it. So let's see, we've got our keys here. We'll add a new piece of state that we'll call buttons. And this will be a record of strings and input buttons. We could do like a map here, actually. Maybe we should. Maybe that would be better. We could say buttons equals new map string input button. We could do that. Anyways, so then we'd have in here, we would say register inputs. Now when this is a proper library for us later on another project, this part would happen outside of this library. We would not be doing it in here, but for now we're just going to do it here. Which we could, forget it. We'll go ahead and add a thing. So we could, well, because what you'd really want to do is be able to, if you had it fully wrapped up like that, you would want to be able to add, like, you'd give it like a list of key codes or a list of gamepad things, and then it would like read the list and set up an update function for you and whatever. We'll keep it simple for now. So we input buttons, and so we'll call this move left. And that'll be a new input button. And right, we need to do set, and this will be move left. Do it like that. So then we're going to have move right, move up, move down. So that's those. And then we're also going to have, well, in fairness, this is Game Boy, isn't it? So we should just get rid of some of the not tight. Up, down, and then we'll have A, B, select, and start. Now I could maybe uppercase those or something. For now, we'll leave it like this. So there's those, and given that it's given that we're doing this for Game Boy Jam, we could go ahead and do this. Enums are not great in TypeScript if memory serves, but we can say export enum GB button. Let's say. What's the problem? Yeah. Okay. So now what I'm going to do is I'm going to grab these. I'm going to copy them. Going to paste them. Going to grab them again. And then we're going to say transform to uppercase. And then we're also going to copy these. We're going to make them string values. Okay. So it's a string enum. So we're doing that. And then here, what we're going to do is we're going to grab all these, copy them again, come down here, okay, and then we're going to say button dot publiam, and I screwed up a couple of them. So there's that, and we're going to use these to refer to them so that we don't typo them anywhere. So now we've got a place to store all of these inputs, right? So then, let me see. So we should have an update function for we're going to take a delta time here. I don't know if we'll end up using it or not. So we're going to have this, and so let's see. So So we'll say this buttons get, or well, we should just do this. Or well, So what we'd like to do is have like for each button update its keys and gamepad buttons, right? But we haven't set up enough to really do that so far. We're going to be hard coding things and we can make them generic later. So let's see, this buttons get button left. So we don't really need the map per se here. It's not really doing us any favors, I should say. I could just make this like an array, for example, since we're not going to be registering any more of these, right? Record string. Ooh. Oh, forget it. Yeah, this is a little bit goofy, but we'll go ahead and do it this way. So we're going to grab this whole thing, and we're going to copy it down here. And then we're going to change all, well, if I could type, good lord. Change these to get. And then we're going to call update on each one of these. And on update, so for the left one, we're going to say is key down, arrow left, or is key down A. And then we're going to do a similar deal on all of these. Arrow right, should it be lowercase a? Or wait, isn't it like, hang on, I think it's like key A or some crud, right? I believe so. Is key down, key D. Oh my lord. Boop. Nope, okay. Is key down, arrow up. And actually, these will easily fit. They don't really need to be on another line. Arrow up or key W. This dot is key down, arrow down, or key D. And then typically what I would do for this is I would have A and B be like Z and X. I think that's pretty standard. And then start is usually escape and select is like escape or enter, and then maybe shift for select. I'm not sure if that's what we want to do there or not. So for this, let's do key Z for now. And for this, we'll do this is key down, key X, and although escape has particular meanings in the browser, so maybe we shouldn't use that at all. Maybe select should be like A or something. Is it just key shift or is it like key left shift or something, I wonder? That I'm not sure about. Could also make it like space or something, I don't know. Let's try key shift, or we could go look. MDN key codes. And okay, so we got a full list here. Key shift. Nope. Shift. What the heck? Shift left and shift right. Okay. So we could say shift left or shift right. That's an option. And then for start, Is it just called like enter? Yeah, okay. It's just called enter. So I'll try that. And one of the things we could do is like have a display on screen of what these are outside of our canvas. For example, that is something we could do for fun. So in here, let's have inputs div. HTML div element or null equals null, and so then in the constructor I'll say this dot inputs div equals, how do you make a div? I forget. It's like document, I mean there's append child, but this is goofy. Normally we would just render something for this, but I'm curious how annoying it would be. MDN JS add a div to the page. Document.create element. Okay. Create element div inputs div inner text. Okay. Failed to execute append child. Only one element on document allowed. Right. So instead of document, what we want to do is like wait a second, that doesn't make sense. Can you not do that? What if I did that? I don't see it anywhere. Okay. Well, I don't know how that would quite work either. So can I get the like parent element, parent nude? Alright. Well, it can't be. Okay. Okay, so there's that. We could also go and add an ID somewhere. So is document.body something I can do? I don't remember. We're going to see. So what if we did document.body? Yeah, okay, I'm not crazy. Cool. Sorry for the detour. Okay, so now we've got that, and then what we can do is here in this situation, which we could just do that in the inputs. So up here we could have, let's have this where we have we'll have debug as const, and we'll say show inputs div true. So we'll have that. And then here in input, what we can do is flies are driving me absolutely bonkers. So here what we would do is we would say if config debug show inputs, then we'll try to get or create the inputs div. So we'll have let div equals document by ID inputs debug or something like that. Or then what we'll do is we'll say if not div, then we'll say div equals document create element div, and then document body append child div, and then we'll say div dot inner text is going to be, we're going to do a goofy thing here, I think. So let's do this buttons for each. Actually, hang on, we'll do this. Can I, oh no, I can't do that, can I? Entries, can I do, no? They're all iterables, but not keys. Oh, fine, I wanted to be cute. So, do this, buttons for each, and so this will be button, key, and then in here what we'll do is we'll add on some stuff. So we'll just have string interpolation is slow, so we're not going to use it. So we'll have button down. Well, we could just do it this way. Fine, I'll do the interpolation. Button down. We'll have key. And then we'll have whether it's down or not. And then we'll have a new line. Actually, that will be literal, I think, won't it? So we'll do it like that, which is silly. And then we'll have div.innerText, not HTML. Come on now, equals S. And we'll have some problem. Or not, will we? Oh yeah, it is rebuilding, okay. So we're just screwing something up there. That is true. Oh, right. We're just appending divs all over the place right now. Maybe not. Something is mistaken there. My window is dim again. Ugh. If anybody knows how to turn off the dimming on an OLED, on a big OLED LG TV, I think it's LG, right? Is it LG? I don't remember. It's like a giant 4K thing. It's like having 6 monitors in one monitor. It's great, but it dims itself to save the pixels, and I can't see, and it strains my eyes. Kind of defeats the whole purpose of having it. This is running, right? No, it is not. Oh, right, we're not even calling update on the input yet. Duh. God. Okay. This input update. That might help, huh? Sheesh. Yeah. That's much better. Man, I'm out of it. That is so embarrassing. Don't need this. Don't need that. Don't need that. Okay. So there's our inputs div. And then we could also do something like we can go in our little CSS file, which we could just do the styling in here. Let's say div style equal. Is that just like a string? No. Okay. So we could just do some CSS in here. We could say position absolute right 8 pixels. Sweet. And then we could do something like font size 10 pixels. That's way too small. And so now we've got our little display here. We could also probably change it to I don't even know what the monospace, what you'd even write here. but that'll work. And we could also do something like, we could pad this out. So let's go and add a new miscellaneous thing called string util. How should we name this? Let's do it this way. String util.ts. Or we could call it like string extra or something. And so we'll have export function pad. We'll have export const string util as const, and then what we'll do, what am I doing wrong here? Right, you'll see. Okay, so then we'll have function pad, which will take a string and a length, and then for okay, we could do that. And then we'll have pad, and then we'll have left pad. We have left pad, which is going to take a string and a length. And then in here we'll say, this is probably dumb. I feel like there's probably a more elegant way to do that, but it doesn't particularly matter for now. What am I messing up there? Am I crazy? We did the same thing here, right? Yeah, you've just got like some stuff. Equals sign. That's what it was. Okay. So there's some little crummy guys. There's probably a snazzier, more terse way to do this in JS, but it's fine. So then what we're going to do here is, for each one of these, let's see. So what we'll do is we're going to change this. We're going to say s plus equals, and we're going to have pad, left pad. Oh, come on, you. Import left, really? From, did I mess up my include paths? Maybe I did. Silly. What's the problem? Oh, right, we can't. Duh. Derp. Left pad is not defined. Yeah, you're no kidding. String util, left pad. Maybe I should make them loose functions so that you can more easily. You could also do both, but anyways. Because these table lookups are kind of grody, but it's so clean and nice. Whatever. Sorry for all my whispering, by the way. I'm not really used to doing this on stream anymore. So key is guaranteed to be a string already, and it needs to be like, what, like, I don't know, let's call it like 12 or something, and then plus plus sure. That is not working. Why is that not working? Excuse me. What's the problem there? None of the things are really that long, so I'm confused. The shortest is like 6, I think. Or the longest is, rather. So what is the problem? It wouldn't be stripping anything, would it? Surely not. It shouldn't matter that a semicolon is there or not. No. Am I just being dumb? Or is it because of how the text... Oh, because it's because of how the text actually gets rendered in HTML. I think we would need to make it a code block. That's my bad. How do you... It's like a code nested in something else. Crap. MDN don't truncate spaces? Like, I don't even know what you'd say there. Oh, I didn't even know that was a thing. Preserve, no wrap. Never even heard of this setting. Huh? Hey, there we go. Okay, sweet. So now I got exactly what we wanted. And we can see our buttons here. Cool. And what we could do is we can change this to, if it's down, we'll say X. If it's not down, we'll do that. Okay. Not so bad. Is there a funny emoji we could use for this? Is there like a button pressed emoji? Not really. Not really. And it messes up the alignment, of course, because those are not terminal appropriate. But anyway, so there, now we can see when our buttons are pressed. Cool. I feel like this is awfully close to the edge. Okay, so there's our inputs debug display, and if we come over here in this and we comment this out, it goes away. Easy peasy. So there's our inputs, and so there's our keyboard inputs, I should say. So we'll say get add all keyboard Game Boy inputs. That took a little while. It would not have taken so long if not for being on stream, but that's okay. So now what should we do next? So we've made a little guy, and had him walk around, we should do... We could add an FPS display, by the way, using this same little trick and not rendering it inside the canvas. We could do the same deal for that. So we could say show FPS true, and we could go add that. So here in game, we would basically do the same deal. It's like we could maybe pull this out into like a utility thing or something. So it's like debug div.ts export function create debug div, and we'll have id, which is a string, we'll have x, which is a number, or well, we'll do this, we'll have style pause, which will be a string. Forget it. This is going to be ugly if we try to generalize it right now. We're going to rip off this mess here, but for counting the FPS. And we'll tidy it up a little bit later. So we'll have seconds, which will be an integer, and then we'll have last FPS, and so then what we'll do is we'll do down here, we'll say FPS counter, and so we'll say const seconds is going to be this game time. Say it's math floor. We're going to floor the game time to get how many seconds it is, and then we'll say if doesn't equal this seconds, then we'll say this seconds equals seconds, and then we'll say this last FPS equals this FPS, and then we'll say this FPS equals 0, and then we'll say this whole thing. So if we should show the FPS, then we'll do FPS debug, and this will be no. Yeah, I'm not trying to do that, you silly. Okay, so then we'll have div inner text equals, and that will be last FPS. Okay, so then the trick is otherwise, in this case, we do this FPS, and it's in the wrong place. Change that to left. Alright, so there's our FPS counter. So we have an input display and we have an FPS counter. Now if I were to go in my display settings, I could change this display from 100 Hertz to 120 Hertz, and that probably just broke my stream, but I have no idea. And so now you can see it's 120 FPS. I'm going to take it back to 100 Hertz, and the screen goes off and it scares me to death. Okay, so there's our little FPS display, and we're going to make this guy a wee bit bigger. So now we have an FPS counter and we have an input display. Not too shabby, huh? We should also maybe we should pull this out, huh? I should probably pull this out. So we'll add a new thing in here called debug div, and so we'll have get or create debug div, where we'll have an ID, and then we'll have pause style, which is going to be where we're putting it. And then what we're going to do is we're going to have font size equals 16 pixels, let's say. And then, nope. Oh, phooey. Really? You're not gonna... Okay. Whatever, I don't even care. Okay, so there's that. And then we're gonna grab this whole deal. Okay. Really? Whatever, man. Okay. Good enough. So there's that. We'll leave this off. And we'll supply that. We'll just call this style, and so that will let us put extra style stuff in at the end, right? And with that, I think that's enough for us to be going on. I also need to set the ID here. Those need to be the actual ID. Okay, so ID, style, and we don't really need to specify the font size there, but we can. We could just as easily put that in the added style, because if we put a font size here that's like 16, and then we put another font size inside this that's higher than that, it'll just override it. So we could just put 16 pixels here and take that off. So ID and style is all we really need. And then we can go nuts with this. So here, what we do is we'd say let div equal, well, const div equals get or create debug div. This one would be FPS debug, and the style would be font size 24 pixels, left 16 pixels, right, or top, sorry, top 16 pixels, and then all of this stuff goes away, I believe. So there's that, and we're in business. So there's our FPS. Simplified it a little bit. Here we're going to do the same thing. We're going to say const div equals get or create debug div. It's going to be this. And the style, whoop. I'm going to say right 16 pixels, top 16 pixels, and I think that's all we actually need to do on this one. Yep. So there's that. All cleaned up. My screen is dim again. Okie dokie. So that simplifies things a little bit. And okay. So that's our FPS. That's that thingy. What did we even say last time? Okay. Debug displays. All right. And so obviously if we change the stuff around, these things just stay where they are. I actually like having them outside the canvas like this. kind of convenient. If you had a lot of stuff going on, updating the page a whole bunch would be slower than if you were drawing it with like WebGL or something. But my intuition is with absolute position things like this that don't affect the layout, it's probably faster to draw this text than to draw text in the canvas. I don't actually know though, we'd have to profile it at scale. I'm also going to change this to have FPS first. So if it changes, it won't be moving around. Let's see. Sorry, I popped my knuckles. See, we've been here for about 2.5 hours, so I might take another 10-minute break and go and plan what we're going to do next. Let's see. Let's do a 15-minute one this time. And hold on. Thank you very much. BRB in 15-minute break. Next up, what are we going to do next? Gamepad input. After the gamepad input, we'll do let's do draw a sprite, load the sprite, show the sprite. Actually, I did not set up a sprite. The program I didn't set up my pixel art program with OBS yet. That's no good. So I have to save that for a little bit later. I mean, we can get pretty far with rectangles. So next time we stream, I could have that set up. So after that, I guess we could do instead simple entity system, maybe? Something like that. And then we would probably call it for the night. I also haven't decided how much work, if any, I'll do off stream for this game jam. I haven't done a jam in like a good couple years, maybe. And I don't know, we'll see. Obviously some stuff will happen off screen because I have a team and I can't really talk with them efficiently and also stream. So what I imagine will happen is I'll try to do most of my programming on the stream. When the streams are over, I'll work with my team a little bit more, and then when I come to the next stream, I'll have things to show, like, okay, well now we have a bank of sound effects for this, or now we have this character art, or whatever. I don't know. But for the moment, I'm going to take a quick little break, and when we come back, we'll do gamepad input. So, BRB. Alright, time to continue. 15 minutes goes by very fast if you do anything at all during the 15 minutes. Okay, so now we're going to do some gamepad input on this bad boy because we want that. So there's actually a pretty solid gamepad API in the browser. When last I used it, it treats all controllers the same. It kind of does an Xbox layout, and that's like the one, oh goodness, that's like the one layout that there is. And so you have to account for that in your stuff. So we are going to quickly do that. So, I don't know what type the gamepad stuff is. Gamepad API. Yarp. So, we'll get, there's like a, what is the function? Navigator get gamepad. That's what we want. Okay. So, let me see here how we do this. Okay, so we'll have another window event listener here. Init the gamepad parts. Add event listener, gamepad connected. Then we have our event callback where we're going to log, we're going to say that a gamepad was connected in the console. Gamepad connected. And then we're going to print out the gamepad. And then we're going to do something with it. So, we could maybe track the gamepads by what player they belong to or some hokum like that. I don't know. Let's see, let's say we have gamepads. Just going to get a record. If we're doing it by index, then that would be a number. And it's a gamepad. So then we would say this gamepads e.gamepad. Oh, there's also we could do an ID. That's also a thing. But whatever. So we're gonna store the gamepad. So we'll have a list of these guys. Although I don't really know if we need to do this necessarily, but we'll see. We'll think about it. And here we'll say window add event listener gamepad disconnected. And when a gamepad is disconnected, we'll log that too. If I could type gamepad disconnected, also show the gamepad, and we will remove gamepads. Does that work? I think that'll do what we want. So now if we come over here and I wake up my PS4 controller, gamepad connected, and we can go look at the gamepad. We can see it's a DualShock 4 wireless controller. We can go and we can look at the axes values when it happened. We can look at the buttons values. And there they all are. There's all the stuff. So now that will track the connects and disconnects, and then I think we need to actually do more work than that to go and get so if a gamepad is already, if we refresh the page, then okay, then it happens on the first input. So even if the gamepad is already connected to the machine, then it will connect to the page on the first input. That's pretty cool. So then, what do we do, like, frame to frame for the gamepads. What do we do for getting our actual inputs off this guy? I mean, we can just poll it frame to frame, I guess, so it doesn't really matter. We need to know which buttons are what, though, is part of the trick there. So if we go here, we need to know the mapping, if memory serves, is like mostly we don't need to worry about that, I don't believe. So we need to go and see, oh, I should also change, well, change that. Ta-da, okay. And so there's an array of the buttons. It has a value or pressed. Now which one is, okay, so the value is for axes, seemingly. And, okay, that's weird. Ball. I'm not sure what that means. Well, we need to know which button to get. So web gamepad tester. Here we go. So here's our DualShock, right? And we can see which buttons are what. So for now, this is a single player thing. So what I'm gonna do is gamepad button down on any gamepad. We don't care which one it is. And this is going to take an index. I'm going to make this internal for now, and this is going to do this gamepads. Oh, I need to be able to iterate this actually. So we'll make this a map. And then this becomes set. And this becomes, is it remove? Is it, what is it? Well, that's not right. Oh. Remove, clear, delete. Ah. Okay, so there's that, and then down here, we'll write this helper. So for each pad index, and we don't really care about the index. So for each one, so we'll do that. So if pad buttons button pressed value pressed or pad buttons button value greater than 0, I believe, is what we want there. Return true. So that's a little bit lame-o, but that should do, I think, what we want. So basically, if somebody has, this is a single player game, so if somebody has like multiple controllers, joysticks, whatever plugged into their machine that are supported by the API, they'll be able to use any of them to control the game in theory. So now we're going to take our controller. What is that? That is B14. So we'll put 14 there. And that's 15. So we'll put 15 there. That's 13. Wait, what was up? 12, okay. So that's 12, that's 13. And now if I save and I go back to our game, I should be able to move with the D-pad. So I can move with the arrow keys. I cannot move with WASD, and I cannot move with the... Well, hang on. Oh, right, because our code isn't actually checking those. Whoopsie. Our code is checking the keys only. So we need to update this a little bit. So in addition to is key down, we need to be able to have is button down. And then, which we could just do that as well. I'll say return this button's name. Right. Get name dot down. Is button pressed. And then we'll do also released. These are just conveniences. Okay. So now we can go back to our game. We can change these to be is button down. And then this will be button dot no dot. We'll grab these uppercase and delete that and update the import to include that. And now, oh come on. Okay, so now WASD works, arrow keys work, and controller still does not work. Now why could that be? Buttons. Press true, touch true, value 1. And that was 14. So what, pray tell, is the problem there? I also don't need this comma here. Anyway, let's go ahead and put in the ones of these for A and B. So let's go and see what, so let's see, X is B0 and circle is B1. So if we were mapping it in Nintendo rules, B1 is A, B0 is B. B0 is B, and then start is B9, and select is B8. Okay, so there's those. We should also do maybe an on-screen deal for this, but that'd make things a little bit easier, huh? So why, and then we also want to map the stick after we get this to work. Do I need to do something goofy like, this should not matter, I don't believe, but just to make absolutely sure I'm not totally nuts. Yeah, okay, that's not relevant. Cool. Oh, duh, because this is inside a callback. Yeah, duh, of course not. Ay, ay, ay. It's just returning from the... Oh, Lord have mercy. Okay, so 4... think that'll be right either. Right, because that will be right. What is this? Number gamepad. So we'll do what the heck? Okay. I don't quite remember how this syntax works. Is that right? Yeah. Okay. Destructuring assignment, 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 assignment. Okay, so now, well, come back. It's like the first input. Oh, okay, so the first input gets stuck, so I think maybe we need to do something like gamepads. Do we need to do something weird like that? Nope. Do we need to do something like update each gamepad or something? How do you... It just goes away. Do we need to Surely it's not a snapshot. I figured if I got the gamepad object that would be like that would be it. I didn't think I would need to, hold on. Do I... Example. Do I have to do that every frame? Do I have to do get gamepads every frame and like redo the thing every frame? Surely not. Okay, well let's try doing this then. This gamepad set pad index pad. Right? Is that insane? Nope. Well, why would that be the case? What does for each actually take here? So why can it be null? That's so strange. So if pad, then we do that stuff. That is also not allowed. Weird. Okay, so you have to do that every frame. It's a snapshot every frame. And now our D-pad works. That is so weird to me. But our buttons also work. So that's pretty cool. Whee! I feel like we should also... We should do like up, right, down, left. Should maybe be the order there. Let's do... Whoop. Well, that didn't work. Up, right, down, left. So we'll have them in order like this when we roll around in a circle. Okay, so that's our D-pad and our A and B, and it's also select and start. Why did my gamepad disconnect? Maybe it died? Or I hit some weird input by accident. Okay, so our D-pad works. Yippee. I guess the set and delete in there don't really matter at all, since it's only a snapshot, which is, again, super strange. Note, I don't think this part matters at all. Okay. So then we want to do the access stuff. So how do we want to do the access? We'll want to have a dead zone in there probably. Is gamepad access greater than on any gamepad? Access is going to be a number, an index. So then we're going to do kind of the same deal here, except instead of checking the buttons, we're going to check an axis. So we're going to say if pad axes axis is greater than, let's call our dead zone something like 0.25. That seems like a reasonable place to start. Then we'll return true. Where we're doing a Game Boy, we really don't care about having a floating point value from this. If we were doing a game where you could have like actual analog input, we would want to remap the value here, but we're not doing that for this game. So then we need to go and we need to use that in here. We need to see which axes are what. So on the left thumbstick, to the left is axis 0, -1, or 0, +1. Okay. Oh, so we need two things here really. Greater than and less than. These are really stupid. We should come up with a better name here. We could do this differently, maybe. We could have like a sum. We could do a sum here. So we could have like, we have something like get access on all, sum access on all gamepads. And we'll take the axis, which is a number. And then what we'll do is what the heck? How did I format this that way? That was weird. Okay. So for each one of these things, we're gonna have and then in either case, we're going to do that. Really, we should remap those two. But anyway, and then we're going to return the sum. Okay, so we're going to do that. And then in here, what we'll do is we'll say const thumb axis x. And which axis is that? 0. I'm assuming. Yes, okay. And so then thumb x. Right, so then we have those. So then what we do is we'd say or thumb axis x is less than 0. Right? Greater than 0. Y is less than 0. Whoop. Y is greater than 0. Okay. So now if I get over here, and here's the D-pad, and then here is the thumbstick, and it feels kind of bad because we're not doing proper stuff on it. Feels a little bit yucky, to be quite honest with you. It does not feel as good as the D-pad. Yeah, that feels downright nasty. Okay. Let's try changing our threshold. We should probably do a real thing here. That doesn't feel great either. The D-pad feels just like straightforwardly good. This feels a little bit crappy. Maybe it's something to do with the sum. So we could try doing this whole deal and see how that goes for us. So on this one, on the two X ones, this would be gamepad less than, that would be 0, right? And this one would be greater than. Silly function names, and then this one would be the same deal but with 1, and the same deal but with 1. And that still feels kind of crappy. Might require a little more effort than this. Anyways, we'll go ahead and change this back to the simple thing we were doing before, since it feels equally crappy. And we'll fix that up later. Let's see. To do. Thumbstick feels yucky. Okay. So, for now we've got some basics going on. We have covered our basic inputs, more or less. So let's go and gamepad inputs. Okay. So that's that. And what's next on my list? So our inputs are more or less covered for now. I think we talked about maybe doing an entity system, and then just like a really simple entity system. Nothing insane. So the core idea for our game, I don't want to spoil too much until we get there, but the core idea is to do something with a bunch of mini games in it. We have an idea about that, and so I have not made a game in that category before, so I've been kind of ruminating a little bit on what the architecture will look like, and I'm still not really sure, but I probably need a simple hierarchical thing. And I might end up, I don't want to try to write my own box 2D in a day during the jam. I might attempt that. I've written physics engines in not a ton of time before, but usually not like rigid body, fun, silly ones. So I might end up having to use a dependency, and it would break my heart. But we'll see. It depends on if somebody really wants to have pachinko or something. Although pachinko's not hard. I can write a pachinko in 2 hours without much physics. Some simple circle checks are enough for pachinko. That was a bad example, but... And my face is stuck. Come on, girl. Why is your face stuck like that? Oh well. But yeah, so let's think about this a little bit. how do we want to do an entity system? We might do like a moderate level of OOP, but not go crazy. Just like one flat level of inheritance generally. If a minigame itself is an entity, there could maybe be 2 levels of inheritance there. Beyond that, we could maybe do something like actually, here's what we can do. We can put that stuff here. So we'll say unlucky entity system. And then what we'll do is, instead of the index HTML doing this, we'll call this like caption. And we'll call this title. And then we'll come here and we'll do it in here, where we will say config description, and this one will be config title. And I oops, bottom text, top text, there we go. Perfect. Okay. So, let's do like the bare minimum silly thing, which is there is an entity and it has, did you do that here? I don't remember how this works, dog. I haven't used TypeScript that much in a little while. So we'll have like on added to game will be something you can do. On removed from game. On what else will there be? And then we can add other various things in here maybe, and then we'll have like on update, on draw. This is very old school and not necessarily ideal, but that's okay. Usually in C, I'm writing things like this, where it's like for thing in list of things, and then do whatever, and like that's just like a commented update the enemies or something like that. I'm never writing anything oopy these days, but that's okay. So we'll do something like that. And then, man, it's hard to think. I'm getting a little bit tired. I'm also mumbling a lot. That's my bad. I'm trying to think about how I really want to do this. Let's see, we should probably have something like an ID for these guys. Something like that. Maybe they can have a name, that'll be useful. Are there sets? Yes, we could maybe have something like tags. Something like that. So we can search things by different things. And then we'd maybe have something like is in game, which could be useful for certain stuff. Because maybe you can call functions on this guy when he's not in the game, but he needs to do certain things. We could also pass the game into all these things, but that's maybe a huge pain, I don't know. Let's see, what else do we do? On, let's change the wording here. On adding to, we could also have scenes instead of just the game, but for now it's fine to have it just be the game. And then, let's see, we could also have on debug draw. And we could do some extra stuff in there. Okay, so there's some basic CRUD, and then some basic stuff, and then we could have like, strongly debating just dragging in my own vector2 class from a different code base. But we can wait and do that momentarily. So let's say we do this. So then in game we'll have some stuff. So let me annotate these real quick. So we'll have like entity management. We'll have something like add entity. Oh, come on. And then we'll have something, say, let's see. For now, let's just say we have a list of entities. Like this. And we'll say this entity is, oh, well, we also need entities by ID, which will be a record of, or should it be a map? I don't know what the real difference is, frankly. I don't know what the, like, number entity, so we'll do that. So we'll say if this entities by ID has entity ID double adding entity, and then we'll have the entity there for convenience, and we'll just early out. Otherwise, what we'll do is we'll say otherwise what we'll do is we'll say this entities push entity, and this entities by ID set entity ID entity. We could maybe keep the entities in lists based on their type of value, because then derived entities would all be kept in separate arrays, which I quite prefer. And that's generally what I do in languages like C, is I'll just have separate homogeneous arrays for things and update them in a set order, which is nice. Like each class of thing in a set order. So maybe we could do that. To do store entities in separate homogeneous arrays by type. Update each type of entity in a specific order. We might not end up needing that for this game, but that is generally the sort of thing that I do. So there's add entity, and then this entity, and then we'll say, can I just do a circular import? I don't know if that's allowed. Are there getters in this language? I don't even remember. It's been so long. Can I do that? Am I allowed to do this? It sure seems as if I am. Gross. Pretty cool though. Okay. So then we'll also say okay. So let's see. And so then what we would do is here in the game, say this, we would say entity game equals this. And then we would say entity on adding to game. Or should we queue these up and then do it after the frame? Let's queue it up and do it after the frame. That makes a lot more sense. Added entities. Entity array. Removed entities. Entity array. And we're going to rename this entities added. Entities removed. Okay. Easy peasy. So we're going to take that off and we're going to say well, if you're adding it, you want people to be able to refer to it. So maybe we do need to call that immediately. That's really disgusting, though, is the thing. I don't like that, necessarily. But maybe we'll allow it for now. It's a game jam, baby. It's a game jam and not our normal language. I think probably around 6 p.m. here I'll need to call it for the night, but so we'll have remove entity. All that would actually do in practice is do this. Something like that. And then on the actual entity, there'd be something in here like remove. Let's just do this. Okay, and then we would do something like at the end of the frame, you do something like this. At the very end of the frame, length is 0. So handle removed entities. So we do this entities removed for each. Entity game equals null. Removing equals false. And then we need to do something like to do remove an entity from any tracking system and validate any handles. Something like this. And then for draw, now we need to do some other stuff. So like we need to go through here and we need to say draw our entities. So we need to say this entities for each entity. Now array for each used to be slow, and in Firefox I think it still is, but in Chrome it is not slow as long as well, it's not slow if you're doing it on homogeneous things. Where these things are not homogeneous, maybe I shouldn't be doing that. But we'll try it this way for now. It's easy to change if we end up not liking it, if it ends up being slow or something. Entity on draw. So we'll do the draw. And what we should do here, honestly, context. We're going to have like we should make a renderer or something. Probably. How are we doing the... So we are storing the canvas, and then we're getting the context, and then da-da-da-da-da. Okay. Maybe we should pass the context in, or we should have like a renderer that we pass in or something. Anywho. So here we're going to draw all of our entities. We should maybe do something where if the entity is not being removed, so like... we should do something like... if not entity removing, for example, then we should draw it. Actually, there's one more thing we need to do here, which is we need to do this entities key. Oh, I can't do that. This entities equals this entities filter e not e removing. This is not the most efficient way to write that, but that's okay. More drawing. So we need to also do debug drawing here. Debug drawing. And we'll say if not entity removing, then entity on debug draw. And then so there's all that, and that's all fine. Oh, close. Let's see. This is orange, right? Like, this is not chocolate. Why is this called chocolate? Anyway. So then we need to also do some other stuff. So before we do this, we need to do entity on removing from game. We need to do that before. And we should probably do like we could wrap these in a try catch so that the game keeps running if one entity breaks, and then we can look at that one entity, but I'm also fine just like having the thing explode. And getting a caught in the debugger, that's much better for me currently. Let's see. So now what we could do is make our little fake player. We could make it into an entity if we want to. That could be something. We can do folder, entities. We can make a new one, which we'll call test square. We'll call this player square test, or just test square was fine. Test square. Export class test square extends entity constructor where we'll have we don't really care about that actually. So now what we're going to do is we're going to go to, we don't need that right now, we're going to go to blah, 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 blah. going to go over here. We're going to grab all of our little things here. We're going to bring them to our test square file. And then all of these need to be overrides, I think. So we're not actually doing anything with that. And these should all be override. And then we're not going to be using most of them for now. So now we'll have an update. And an update, we are going to do this stuff. So in update, we'll do all of this crud. So we'll take this out. And we'll put it in here. And we'll have and then when we're adding to the game, we'll say that this.x is going to be config game width over 2. Right? And we need to import this. And we're going to say console log test square added. Test square removed. And const game equals this game. We're only going to do this if the game exists. Which we could also just do this game. It's all fine. But that can be no. What if we do a little fib? What if we do a little like what if we do this? Or wait, no, it goes here, I believe. No, that's not right. Crap. Is that what we do? That allows it to be null, I believe. And then it'll explode if it is. Which is what we would want. Okay, so instead of this dot player dot whatever, it's just this dot. And so we'll go ahead and put this speed up here. 64. Okay. So there's that. And then we'll go to our on draw and we'll move our draw stuff in there, which for now is going to be kind of gross. Because we don't have a renderer yet. So then here in the drawing for our little player, I'm going to grab that, bring it in here. Oop. Okay. Alright, so there's that. And then what we'll do is we'll go back here and you'll notice now our player is gone. So what we'll do is on our init, we'll do this add entity, new test square. And we have a problem. Canvas. Okay, what is the issue? This game canvas. Right. Because maybe the time that's happening. Well, now we take the canvas there when we construct the game, right? What's the problem? Is it because Okay, let's see what add entity does. Add entity. Okay. So we add it to the list, we do that, we set the entity game, we call on adding to game, which for our test square doesn't do, or it does do a couple things. Did we see that? Did that print test square added? Yes. And then we have on update, and then we have on draw. Why is that not set? Is it because game is null? Let's look and see what we can see. Oh, we're not paused. Why aren't we paused? Excuse me. Pause on the breakpoint, please. Pause on the crash. Pause on uncaught exceptions. Oops. Okay. So now I can look at our locals. W. What the heck is that? That's our player, I think. Did I write... Did I write the, Did I write this wrong? Let's see. Is in game is false. Well, that's not good now, is it? Well, but the game is here. The game is here, you silly. What gives? Like, am I stupid? I mean, I know I'm stupid, but... Oh, now it's just like, fine. What? Well, that's not fine, seemingly. Which also... Oh, my gamepad just died again. I need to plug it in with the cord, I guess. Where is the cord? The cord is somewhere. The cord is not here. The cord is on vacation. Okay, so why is that not working all of a sudden? Is this actually running? Let's see. No, it is not running. Okay, so on update is not running for our guys. Oh, right. Update entities. Actually, we should probably just do it indiscriminately for now. Ah! I went to the other desktop by accident. Okay. We should update them, but we shouldn't draw them. I think. Well. Okay, so now we're back in business here. Cool. So we have a crummy entity system. I'm trying to think what we could quickly do with it to test it out. We could make the world's worst brick breaker or something like that. I don't know, we could make some things that move around or something. Actually, folks will be getting home at my house soon. Let's see. So I think I might call it here momentarily. So today we set up our game loop, we set up our canvas, we set up some keyboard input, gamepad input, and we also set up a very crummy entity system. Now next time when I come back, I'll probably have some rudimentary pixel art, and I'll have some sounds and music maybe. And next time we'll look at using asset files, maybe setting up a little preloader. We'll look at setting up an actual renderer using our canvas that has just like convenient functions for doing things. Maybe we'll have like a command buffer. It's like we'll have a command buffer of sprite drawing commands, so that we can have all our entities draw themselves and then like do things like depth sorting on those draw commands and other goodies. We will, let's see, probably do some bitmap fonts next time. And then since our current favorite idea is centered around minigames, we'll probably start doing a little bit of architecture around that. So just like having a game with lots and lots of, like having a core minigame architecture set up that each minigame can use, and like spawn other little things within itself, and then have like some shared state between them and la-di-da. So we'll mess around with that next time. So I won't be streaming. I might stream tomorrow morning. I won't be streaming tomorrow afternoon because I have plans. Currently, I should be able to work on the game and stream some on Sunday. So I'll see you all either tomorrow morning or on Sunday. But thank you for joining me for this first little bit of work on Game Boy Jam. I'll probably do some work off screen, but if so, I'll talk about it when I'm on stream again. But thanks everybody who dropped by. I appreciate the company. I hope everybody has a good night. Laters.